Hello. This video is going to be somewhat shorter because all we'll be dealing with is how do you get energy from power. You may recall that we're often interested in how much energy is delivered and how quickly. At the same time, we still might be interested in knowing how much energy is being transferred in my circuit as a whole. So, we need to get energy from the power. If you remember, power has the units of joules per second. So to get rid of that seconds, we need to integrate with respect to time. So the energy is equal to the integral from t1 to t2, p of t dt. Now, what do I really mean here? t1 to t2. This is in fact a change in energy from my initial time to my final time. And my initial time is t1 and to the final time t2. I typically don't use an indefinite integral there. Typically it will be an indefinite integral because I'm curious about the quantity of joules, the quantity of energy. So the unit, just to make sure that is clear, is the joule. Let's do an example. And this is going to be called energy from power. We're actually going to begin the same way as we began the last example in the last video. I'm going to set up a circuit element with current and voltage. We're going to find the power, and then we're going to find the energy. So my generic circuit element, I'm going to say this voltage here is positive 10 volts, and we're going to assume the current is going this way, but I of t is negative 2 amps. So the first thing we need to ask ourselves is which of the terminals in my circuit element is the high energy terminal and which is the lower energy terminal. Since my 10 volts is positive, that means as we move from A to B with positive current, we gain energy, which means that A is the lower and B is the higher energy terminal. The next thing we have to do is keep our signs consistent. Taking a look at my current, I have a negative. When I have a negative current, what that means is that the assumed direction was incorrect. So we need to redraw this, allowing for the current to go the other way and have a positive magnitude. I'm going to just erase it so I don't redraw the whole thing. And my current is going this way. I of t is 2 amps. Now, we have positive current entering positive terminal, which means the sign that I'm using is the positive. Power is a function of t, even though everything else is constant, is 10 volts times 2 amps times positive 1. So power of t is 20 watts. Now we need to find the energy from this, and we integrate. But integrate from what to what? Notice how I just said find the energy. I haven't given you enough information to use that formula we've just derived. So let us allow t1 to be 0 seconds and t2 to be 1 second. Then my energy is the integral from 0 to 1 of 20 dt. This integral is 20t from 0 to 1, otherwise known as 20 joules. There's something else that I want to talk about here, which is I've always been using some somewhat convenient units. Everything has been in seconds, amps, and volts. What if t1 was 0 milliseconds and T2 was 100 milliseconds. Well, I can't just integrate yet without making sure my units are consistent. In fact, one of the biggest things we need to make sure of in this course is that units are consistent. Typically, what this means is we want to make sure everything is in seconds, joules, volts, and amps. So, what I'm going to say is, before I do this, I'm going to change my units. T1 is still 0 milliseconds, I beg your pardon, 0 seconds, because 0 milliseconds and 0 seconds are the same. T2, on the other hand, is 0.1 seconds. Now that everything is in seconds, volts and amps, I can say my energy is the integral from 0 to 0.1 of 20 dt, which as before was 20t, from 0 to 0.1, which now gives me 2 joules. So to recap, to get the energy from the power, it's a definite integral. In order to make sure everything is consistent, my units must be joules, volts, amps, and seconds, and watts. If that isn't the case, I should convert. I should make sure that my units are consistent, or else I'm going to get the wrong value. Thank you.